Hi there, 8th graders. It's Mr. Pouts, and you're watching the section 2.1 video. This is the first section of chapter 2, where we're talking about solving equations in this chapter. Some of you love this, some of you maybe don't, but the goal here is to become masters at solving equations. So our first section is going to deal with those one-step equations. We're going to do all four operations, either addition, subtraction, multiplication, or division, to solve our one-step equations for this section. And then from there, we'll go on and do two-step equations, multi-step equations, and we'll get some more challenging things from there as well. But make sure in your goal sheet, you write down this is the goal or the objective for today. That would be to solve one-step equations in one variable, meaning we're going solving these equations are going to take only one step, and they're all going to only have one variable in them. All right, so that is our goal. Here's a little vocab for you first. So the two words for this chapter that we're going to start off with here. The first one is called inverse operations. So maybe you remember inverse operations are operations that undo each other. So, for instance, and I'll make a little chart here. So those are operations that undo each other. We'll say this is the operation. This is the inverse operation. So if I'm going to say my operation is adding, what would you do to undo addition? Well, you subtract. Those are opposites. Subtract. Got a little weird there. All right, what if your operation is subtract? Well, what would you undo if you're subtracting? Well, you could add. Adding and subtracting undo each other. Just like a positive and a negative of the same number would undo each other. They'd get to 0. All right, multiplication and division is a little bit different, but if you were to multiply, you're trying to undo the multiplication, you would divide. And if you are dividing and you want to undo that division, divide, then we would multiply. So those are all the opposite or the inverse operations. All right, and the other term here is called to isolate. And we say isolate, maybe you think of playing basketball, playing football, and you want to isolate one of the players who has the ball. You want to get them all by themselves. So in math, we're going to get something all alone, or to isolate the variable, we're going to get the variable by itself. So that's what it means to isolate. All right, so if we're going to isolate a variable, we're going to make that all by itself on one side. So those are our two key terms for today. And so we're going to go on. Now, you might have heard this, you might have learned this last year or the year before. This is a phrase that you should stick in your head. Write it down in your hand, write it down on your shirt. Tell your friend that what you do to one side of an equation, you must do to the other. So for instance, if you're going to, and this is when we're talking about inverse operations, if you're going to add something to one side of the equation, in order to keep it in balance, you have to add it to the other equation. If you think of a balance, a scale, and I can't draw a scale the best, but let's just draw one like a teeter-totter almost. You got the little triangle in the middle, you've got this thing. Right now it's balanced, but if you were to add something to the one side, it would then become unbalanced. It would look like this. But to balance it back out, we would need to then add the same thing to the other side. All right? So, some legal operations that you can do to both sides are right here. These are the properties that we're going to talk about first. If you want to write these down, you can. I'm not going to. That's up to you. These examples are great. I would definitely write down the examples. But the first one is called the addition property of equality. The addition property of equality basically says adding the same number to each side of an equation produces an equivalent equation. So meaning that both sides are still going to be the same. So if A equals B, then you can also say then A plus C would equal B plus C because you're adding that C to both sides. An example here, if you have X plus or x minus 3 equals 2. Really, you can do whatever you want. You can add anything to both sides if you want. What I'm going to do is I'm going to do x minus 3 plus 3, but then I have to add, so then we have 2 over there plus 3. The thing that I did to both sides was adding the 3 to both sides. So then, the nice thing about this is actually how you'd solve an equation, because then the right side you end up with 5. The left side, when you have minus 3 plus 3, those are opposites. So you'd end up getting just x plus 0 or just x. All right, subtraction is the next one. Subtraction property of equality would again be the inverse of addition. So this property here says that subtracting the same number from each side of the equation produces an equivalent equation, so it would be still equal on both sides. So basically here we're just subtracting, in this case, with a equals b, you can subtract c from both sides, and that'll keep it in balance. So right here, let's say we have x plus 3. I'm going to make the example where I'm going to subtract 3. Maybe you remember this. If it's plus 3, we're going to subtract 3. But then if we do that to the left side, to keep it balanced, we have to subtract 3 over here. So then you're left with just these cancel out. You're just left with x. And 2 minus 3 is negative 1. So x would be equal to negative 1. We got that one right there. All right. Next one, the multiplication property of equality. So that one says you can multiply each side of the equation by the same non-zero number, okay? And it would produce an equivalent equation. And technically you could do 0 if you wanted, but we're going to keep away from 0. So if we're going to multiply, and here I have the example shown for you. But if a equals b, then a times c equals b times c. Our example right here, we just have x divided by 3. I know it looks like the fraction x over 3, but that's the same thing as x divided by 3 is equal to 2. And what they showed in the example was I can multiply whatever I want by both sides as long as I do it to both sides. So I'm going to multiply 3 by both sides. That is totally legal. You'll find that would actually cancel something out, and you end up getting x is equal to 6. Because 3 multiplied by this side would be 3 over 1. And that would actually cancel out there. Last one, division property of equality. The division property of equality states that dividing each side by the equation of the equation by the same non-zero number. And this time you can't divide anything by 0, so we're going to stay away from that. So if you divide both sides of the equation by the same non-zero number, it would produce an equivalent equation as well. So in our example, if a equals b, then a divided by c could be equal to b divided by c, whatever c is, as long as you divide both sides by that c. In our example here, we have 5x equals 20, and we're going to divide both sides by that 5. And you'll find out then these would cancel out. You'd end up just getting x equals 20 divided by 5, which is 4. So those are the 4 legal inverse operations that we're going to use to solve equations. And we're going to do some more examples of those in just a moment. Before we do that, why don't you stand up, pause the video if you need to, and go give someone a high five. I want to see you do it. All right, so now we're going to do solving a one-step equation. So you've done solving equations. You started in 6th grade. Really, you started it long before, because you used something like, I'll give you an example here, like box plus 4 equals 6. Basically, you did solve equations. You just figured that using your knowledge, 2 plus 4 would equal 6. So you did solving one-step equations a long, long time ago. But formally, you started learning the correct process for doing it so that you can do harder ones just in the past couple of years. But you've had lots of practice with it, and we're going to do some more. So this one is just about one-step equation. So here's the steps to solving one-step equations. So first you need to isolate the variable by using the correct inverse operation. So the inverse operation of what's going on. Then simplify both sides, and ultimately you'll get the answer for your variable, and then check your solution by plugging that solution back into the equation. So the original equation. So what I'm going to do is I'm going to give you a couple examples here using these different ones, and I'm going to also use these blocks over to the right for a couple of them, just to see if you prefer seeing that visual. So we're going to start with x plus 13 equals 27. So if I have my x is my question mark. So I have x, and then I have 13, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we know that's all going to equal to, oh, holy cow. I'm just going to write 27 for this one. And I'll write it in green so we know we have 27 over here. So my question for you now is, how do I undo that? How do I undo? We want to get just this thing by itself. We want to isolate this thing right here. Oops. Wow. So we want to just get this thing by itself. So we want to get rid of everything else. So what we can do to cancel out all these positive ones is we can add in some negative ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And now the nice thing about that is that, I'll move this off to the side, I don't know why that came apart there, is that all of these, anytime you add 13 ones and negative 13 ones, or subtracting 13, they all go away. And we're just left with whatever our question mark is equal to, but our balanced equation is not balanced, so we have to subtract 13 over here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 27 and a negative 13 will get you to 14. So our question mark, our box would be 14 if you're looking at that right there. Now, if you just want to write it out the easy way, now some of you prefer that visual, some of you prefer this way. If you look, x plus 13 equals 27. First step, we're trying to isolate the variable, so our variable is x. How do we get the x by itself? Well, we use the inverse operation of whatever's next by it. So the inverse operation of addition would be subtracting. So I'm going to subtract 13. Now it's up to you if you want to write it like this. I'll show you that. And you'd cancel these out. Positive 13, negative 13 cancel out. And you just have x's by itself before 14. Or, and the way that sometimes works better is to do it side by side. So x plus 13, and then you can subtract 13 from both sides. Do the 27 minus 13. This positive 13, this negative 13, again, cancel out. That's just 0. So you just have x left over here. And then 27 minus 13 is 14. So either way, this way with the blocks, the first way going underneath it or going next to it, you all get x equals 14. And how do you check that? Because it says simplify both sides like we did there. But then we need to check it. So let's plug it back into the original equation. So I'm going to check it in red here. So x is 14. So let's plug that back in there. So 14 plus 13. Is that equal to 27? I sure think so. 14 plus 13 is 27. And then we give ourselves a smiley face because we just showed our work. We proved that it actually is correct. All right, let's try one with subtraction. So this example right here, we have negative 7 plus b equals b minus 3. So what I'm going to do right here is I'm going to get rid of all this stuff. I'm actually going to get rid of this too because I don't like that one. So I have negative 7 on my one side. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. And we're going to say that is equal to this b, this question mark, and then minus 1, 2, 3. Now our job is always to get this question mark all by itself, this b value. So to undo these negative ones, we're going to add 1, 2, 3 to that side, so that those are all gone. But, like we said before, you then have to add 3 to this side. 1, 2, 3. What you do to one side, you must do to the other. And then these 3 are gone. So what you're left with is this question mark, b equals negative 1, 2, 3, 4. Negative 4. All right, or if you want to do it the algebraic way, you can do, we're trying to get the b by itself. So this is a subtraction. We're going to add 3. So you end up getting b minus 3 plus 3 equals negative 7 minus 3. These will cancel out then, because negative 3 and plus 3 would get you to 0. So you just have b, which is what we wanted. Then negative 7 minus 3 would get you to go farther back, so it would be negative 10. Oh, I meant to plus 3, because this is adding 3 over there. My bad. If we would have checked that, we would have found that it wasn't correct. That would actually be negative 4 then. Now to check it in red, we are going to go negative 7. Is that equal to negative 4 minus 3? Well, I think that is negative 7, so negative 7 equals negative 7. Give yourself a smiley face. All right, 2 more examples. I'm not going to do the bricks for this one. We're just going to do the inverse operations for division and multiplication. So right here we have division. So to undo division, we have to multiply this whole side by 4. Multiply then this whole side by 4 to keep it legal. On this side I can simplify pretty easily in our step 2. That would be negative 36. But over here, how do you multiply fractions? Well, let's make this into a fraction. Then you'd end up with 1 4 on top. That'll cancel out with this 4 on the bottom. You're just left with x over 1, or x. That is equal to negative 36. When you check it to plug it back in to check it, you go plug in negative 36 for x over 4. Is that equal to negative 9? Well, you can check it if you need to, but that is negative 9. So smiley face there. Last one, 2x or 10 equals 2x. So think, what does it mean when you have 2 with an x next to each other? Well, that's multiplication. So we're going to undo it with division. And this I'm always going to do underneath. Divide it by 2, divide it by 2. So 2 over 2 becomes a 1, or just 1x, which we know is just the same as x. And 10 divided by 2 would be 5. All right, I'm going to check it by doing 10. Is that equal to 2 times 5? Well, 2 times 5 is 10, so you betcha. Give yourself a smiley face again. Okay, those are basic one-step equations that you can solve using those inverse operations. Now, before we're done, I want to do one more thing. I have 2 troublesome examples that I see students struggling with, all different students struggling with. So I wanted to go through 2 of these examples. And believe it or not, that first one is a one-step equation. So what we're going to do is we're going to figure out inverse operations. But before we do that, if you ever have a minus x or a negative 1 or negative x, always stick a 1 in there. You can always stick a 1 in front of a variable if there is no number in front of a variable. So now we have negative 1x equals 8. And really, in this one, I'm going to do the same thing. This will actually turn it into a 2-step equation. Oh, that's okay. So 4 minus 1x equals negative 8. So this one right here, then it's the number multiplied by x. We're going to divide both sides by negative 1. We get x, these cancel out, equal to 8 divided by negative 1 is negative 8. you can check it by plugging it back in. You'd have negative, or whatever our x is, so it's negative 8 equals 8. These both are positive, so 8 equals 8. Smiley face. So last one then. I changed this to a negative 1x. So you might not remember two-step equations, but we're going to do those next time. But put a 1 in front of the x again so you know what's in front of the x. Now, if you remember from two-step equations, you kind of go a reverse of order of operations. So you don't do the multiplication first and division first. You do backwards. So you're going to do the addition or subtraction first. And this right here, this negative, I know it's subtraction, but it does not go with the 4. We're not trying to, this is a positive 4, so we're going to undo the positive 4 by subtracting 4. And we'll subtract 4 over there. And if you prefer to rewrite it, which I'm going to rewrite it actually, like this. So 4 minus 1x minus 4 equals negative 8 minus 4. Negative 8 minus 4 is going to be negative 12. And this is where you have a positive 4 minus 4. Those cancel out. And you still have that minus 1x though. And then our last step would be to do that division or multiplication. And since this is multiplication, the inverse would be dividing by negative 1. So x should be equal to 12. And if you wanted to check that, you can plug it back in and get 4 minus x is 12 equals negative 8. And that would be true because 4 minus 12 is negative 8. So that's all we have here. Oh, smiley face. So I almost forgot. That's all we have here for section 2.1. That is on solving one-step equations in one variable. Make sure you self-assess yourself after this lesson again, and then go on to do the next work that's given to you. All right? See you next time.